Welcome, welcome. We are on the home stretch here. We're on 207, 208. Let's go ahead and add some notes on these questions. It's been a while since we reviewed this word. It says, in the design of a survey, which of the following would best explain the response bias? So I'm going to review what that even means. In the book, there was a couple of examples, and sometimes in class we actually do the activities, where the assignment goes, using response bias, design a study that is purposefully bad. Now, by doing that, it becomes very obvious that the response has been tainted in some way. Let me explain. In this activity in the book, it says a few examples, and I've actually had some students do this. You ask questions like, with glasses on, do people look smarter with glasses? And you actually have the glasses on. And part of that, whether we subliminally or consciously know it, is the person responding bias in some way because of the way we are as humans. We want to tell people what they want to hear. Another idea with this is not just the way we look when we ask the question, but the way we actually say the question. So a perfect example of this in the response bias is either to ask, leading up to trick-or-treating, do you go trick-or-treating? Okay, so walking around, taking a survey, asking that question. Then have somebody else you know ask exactly the same question, but you say the word, do you still go trick-or-treating? Now, just by adding the word still and adding that inflection in your voice, do you think the outcome would be different? And so ultimately, the outcome shouldn't be different. You're really trying to seek out the truth, and either the person goes trick-or-treating or they don't. But notice, by carefully wording a field test survey, that's the only way to minimize it. So we can't prevent it, but we can minimize it by really carefully crafting the way we ask, how we ask these questions. Now, 208, let's take a look. It says, for a sample of 42 rabbits, the mean weight is 5 pounds, and the standard deviation is 3 pounds. What is most likely true about the weights of the rabbit in this sample? So we know for the sample, the mean weight was 5 and the standard deviation was 3. We also know this is a quantitative question. And ultimately, I'm hoping you remember learning the central limit theorem. Change that word from theory to theorem. So the central limit theorem states that if you're collecting quantitative data, even if the data is skewed or bimodal or any other shape under the sun, if you're taking a sample of that data, a sample of it, the sampling distribution will eventually become approximately normal, and this naturally happens every time we collect quantitative data and anytime our sample is 30 or greater. So yes, we like this approximately normal because the sample size is 42 and because the number 42 is greater than or equal to 30, we recognize that the central limit theorem applies here in this setting. Thanks for joining us.